Hello and welcome to lesson 1.5, Measuring and Constructing Angles. In this lesson, we're going to be talking a lot about the protractor. Now, what you see in this diagram is a protractor, and by the way, we are on page 22. Now, before we start the lesson, let's talk about the materials that you are going to need. You are going to need a protractor, and you are also going to be needing a compass, as well as a half sheet of blank paper. Now for the blank paper, simply grab a piece of paper and fold it in half, just like this. Okay, half sheet of paper. All right, now let me tell you where all those things are going to go. Now this is on page 22. If you turn to page 23, that is where you are going to be gluing the half sheet of paper. Let me put my lights here. That's where you're going to put your half sheet of paper. Now on page 24, write down where the problem numbers are going to go. Problem number 1 is going to go right next to the word angle. Problem number 2 is going to go right next to the word next to the phrase exterior of an angle. And problem number 3 right next to obtuse angle. Normally, I don't really talk about these in each individual one. I'll usually just talk to them in context. Turn to page 25. And on page 25, you're going to be putting problems number 4 right there and problem number 5 up there. And we'll come back to all this information in just a bit. So let's go back to the exploration. Let's go to page 22. Now what you see here is a protractor. A protractor is used to measure angles. So before we do that, I always want to look at each individual one of these angles. Now, since I am reading this angle, for example, the angle is facing the right, so I'm going to use the lower part of the angles. So here, the angle measured by angle BOA happens to be right in the middle between 30 and 40. So that happens to be 45 degrees. So this angle right here is 45 degrees. Now I'm going to use little arc right here so I can show you what I mean. All of this right here is 35 degrees. Now if you want to use a highlighter, you can do that. Okay, so let me do that. Probably highlighters are going to work a little better. So 35 degrees. Okay. Now I'm going to use a different highlighter for the next angle. The next angle is angle COA. Okay, and that angle is this one right here. Okay, and that degree happens to be between 60 and 70, so that is 65 degrees. The next angle, if I can find a different colored highlighter, is angle DOA. That's the larger angle. And this angle right here, according to what we see, is about 110 degrees. So that's about 110 degrees. And then the last one, I'm going to use green, goes from here all the way to E. So angle EOA, that's this one right here. That is approximately 145 degrees. Now, why do we need to know this? Well, here's the thing. We're going to be looking for angles that are in between. For example, this angle, or this angle, or even this angle. So we're going to need to know all those measurements. Okay, so I'm going to need to zoom out in some cases when you can't see the ones at the bottom. All right, let's look for the first angle. The first angle is angle AOB. Now, the measurement of angle AOB, and by the way, this is the notation for the measurement of an angle. Okay. Now angle AOB, that's AOB, happens to be 35 degrees. So AOB is 35 degrees. The middle letter represents the vertex all the time here. So AOB is equal to 35 degrees. The next one is the measure of angle AOC. Now the measure of angle AOC is this one in orange, AOC, and that happens to be 65 degrees. The next one's angle BOC. You're probably noticing that the audio is a little bit better than previous videos, so I just got a new microphone, and it happens to pick up absolutely everything. So if you hear some background noise and my kids are yelling, they're 5 and 3. They do that all the time. But they're fine. They're with their mom. Just wanting you to know, it's just in case you hear some background noise. All right, BOC. Angle BOC. Now this is the first angle that does not start at angle 0. So angle BOC is this angle right here. Now angle BOC, we can find that out by taking the difference between 65 and 35. It's kind of like having a piece of cake, a big piece of cake, and taking off this piece of cake. So that's going to be 65 take away 35, because angle AOC is 65 and angle AOB is 35. So the difference between those two is going to give me this little piece right here. So 65 minus 35, that's going to give me how much? I see 30. Okay. All right, the next one, angle BOE. The measure of angle BOE. That is this angle, BOE. So to get this angle right here, I have to subtract the large angle minus this little piece right here. So that would be the equivalent to 145 take away 35, which happens to give me 110. All right, the next one is angle COE. Okay, so the measure of angle COE, if you look at the diagram, COE happens to be this one right here. So what we have to do is we would have to subtract the large angle minus this angle to get just this little piece right there. Okay, so that's going to be 145 take away this angle, which happens to be 65. So 145 minus 65 gives me 80 degrees. Now, I've been forgetting my little degrees. Is it a big deal? No. But we should really put them. The next one is angle COD. COD is this angle right here. So in order to find that out, the measure of angle COD is the difference between 110, okay, because we're looking for this one, COD, minus this one right here, that's 65 degrees. So 110 minus 65 is going to be 45 degrees. Now, for the last two, we have angle BOD, that's BOD. So for the measure of angle BOD, we need to subtract the 110, okay, because remember we want BOD minus this 35 degree one. So 110 minus 35 is 75. And for the last angle, we have angle AOE. Okay, so angle AOE happens to be simply 145. And that's it for all the angles. All right, now if that went a little too fast, please make sure to pause the video, go back and relook at how I did all of this. Okay, so the next piece is we're going to do actually two constructions, and those two constructions are going to be on the very next page. Do you need to remember how to do the constructions? Yes, because in the future you will be asked to do even more complicated constructions, and these happen to be the basic ones. Those happen to be the ones that are going to set the foundation for the rest of the constructions. So on page 23, you probably should have already glued your half sheet of paper right on top of it. Anything that I have you guys cover from the bottom, it's not really that relevant. So I'd rather you do this. So what you're going to do is, because we're doing two constructions, you're going to divide that paper into two equal pieces. You don't have to cut it. You can just put a line over. I accidentally glued the wrong side. So there you go. Imagine that's not there. So we're going to do two constructions. The very first one is the construction called copying an angle. And the second construction we're going to do is called bisecting an angle. Now there are tons of videos on how to do this on YouTube. If my method is a little confusing, feel free to go on YouTube and put construction, copying an angle, or how do you bisect an angle. YouTube is full of really good videos that will help you learn how to do these. All right, so the very first thing that we're going to do to copy an angle, well, we need an original angle. So I'm going to split this top portion into two parts. One for the original, one for the new one. So on the left-hand side, simply draw any angle that you want. Make the angle sizable. Don't make it too small because it'll be very difficult to copy. So on the left-hand side, I want you to just draw an angle. Doesn't matter how big. Okay, here's an angle. Now, for the sake of clarity, I'm going to be labeling this angle. Oh, wrong letter. Okay, I'm going to call this angle A, B, and C. And our goal is to copy this angle. Now, what I'm going to do on the right-hand side is I'm simply going to draw a little segment. It doesn't have to be the same size as BC because we don't care about the length of BC. We just care about the angle for right now. So you're going to create a line like this. Okay, it doesn't have to be the same distance as BC. Now here's where it's going to get interesting, because you're going to have to turn your paper so that it's facing away from you, so that the angle is facing away from you. Kind of like this. You see how the angle is facing kind of towards the top? That's what you want to do. Now, on this little part right here, I want you to specify a point on that line. Now, from here, you're going to set your compass to really any length. It doesn't really matter, not too open, not too close. Maybe about the size smaller than any of the segments that you have here. Like probably this would be a good size, maybe a little bit smaller. It would work great for this side. I'm going to close it a little bit because I want it to be less than the distance from B to C. So from here, you're going to create an arc that is going to intersect the angle at both places. Now, strong suggestion, put weight on the metal piece and turn the paper, not the compass. Try to do it on a surface where your paper's not going to move much. Now, you see what happened with me? I have a surface that kind of moves a lot. So let me try that again. Okay. Let me move that paper clip out of the way. That's probably what's going on. Okay. We're improvising here. All right, so remember what I said. Move the paper, not the compass. Lean the compass forward and simply turn it. Like this. Now, you see where that angle intersects twice? Here and here. Now, don't open up the compass or close it. Leave it the same. Now, go ahead and put the metal piece on the new point, lean the compass forward, and simply draw an arc. Make sure that arc is visually bigger than this one. The next step is going to be to measure how open the angle is. So from this intersection and that intersection, you're going to measure like this. Pick it up, put it on this side, and lean the compass forward and just do a little turn. Now my compass is a little bit loose. I probably need to tighten up the screw a little bit, and that will happen. Once you have that intersection, all you have to do is put the ruler or the protractor on that point and that intersection and make a line. Now pick a point anywhere on this segment or this line, and I'm going to call that D, E, and F. Now what did I just do? I pretty much just copied this angle and this angle. Therefore, angle B is now congruent to angle E. And this is how you copy an angle. The next construction that we're going to do is called bisecting an angle. Bisecting, if you remember from the last lesson, is cutting an angle in half. Now you're probably thinking, well, how hard is it to do that? You know, can you just draw an angle and then just eyeball where half is? Well, eyeballing is not a construction, so it's not as easy as it seems. So first thing you need to do is construct an angle of any size. Don't make it too small because it'll be very difficult to do. So simply construct an angle. Let's give that angle a name. Let's call that angle X, Y, Z. Vertex, Y. All right, so here's how you're going to do this. Now, when you're doing constructions, please make sure that your area is all clear so that you can easily just turn the paper around. Okay, I had a little bit difficult time because I had the laptop too close and it wasn't moving. So here's why. Move the angle so that it's facing away from you. Set the compass to whatever measurement you want and simply make it cross twice like this. You could keep the same setting on the compass or open it or close it. It won't matter. And from this point and that point, you're going to make two arcs that will intersect in the middle, like this. Watch me. Whoops. I think I need to change my compass. It's a little bit too loose. Okay, from here, slightly turn it, and then do it on this one as well. Okay, I know it's kind of hard to see. But here is the point of intersection where the two arcs will cross. Make sure you align Y to that point of intersection and simply draw a line from there to there. Boom. What we just did is we just bisected the angle. Therefore, this angle and this angle are congruent. Notice that they have the same number of arcs. In an angle, when you want to mark two angles congruent, you put the same number of arcs in it. Now, you can pick a point anywhere on this line, doesn't matter. I'm going to call that B. And what we just did is we just did this angle and this angle congruent. We constructed that. So angle X, Y, B is going to be congruent to angle B, Y, Z. And that is how you construct, that's how you do a construction for bisecting an angle. All right. Now, we're getting ready to do the examples pretty soon. So first, let's turn to page 25 and go over a few things. Okay. Not a big deal. Protractor postulate is pretty much the blend between a half circle, and the numbers 1 through 80. Is what allows me to measure. Okay. Now, when you do measure, you have 4 types of angles. These are not new. It's something that you should already know. The first one is the acute angle. An acute angle is an angle that measures from 0 to strictly less than 90 degrees. If it measures 90 degrees, it's considered to be called a right angle. And you can see that sometimes in a diagram shown by a little box right there. Any angle that is bigger than 90 but strictly less than 180 is called an obtuse angle. And any angle that forms a straight line, like this one, is called a straight angle. Now, postulate 1.4, called the angle addition postulate. Okay, so it's a little wordy. All it is really is that it allows you to add 2 angles together to make a bigger one. Kind of similar to the segment addition postulate, but for angles. So if you have this angle and this angle, when you add them together, you get the larger of the angles. It's the sum of them. All right, let's go ahead and begin our examples. Now, you already know where the examples go, so make sure that you wrote down where they were. If not, go back to the beginning of the video and find out where they go. So let's start with example 1. All right, example 1. A lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name 3 angles shown in the diagram. Now remember that the angles have to have a vertex. So in this case, the vertex would be M. Now there are multiple angles. There's probably more than 3 angles in this diagram, but let's just focus on 3 of them. So let's look at this angle right here. This one right here. Let me mark it. So actually, let me use a highlighter. Probably make it easier to see. So if you look at this angle right there, what would the measurement of that angle be? Well, I mean, I'm not the measurement, but what would the name of that be? Well, there's 2 ways. You can call it either angle JMK or backwards, angle KMJ. Both of them will work. So angle JMK. Look at the notation. If you do not use this symbol, if you just write it like this, that stands for the name of a plane. A plane and angle are not the same thing. So yes, you do have to use the proper notation. And that's the thing about geometry, guys. There is a lot of notation. Can't get away from it. Now, you can either write it like that or the letters backwards. Angles KMJ. What you cannot do is call these out of order where M is not in the middle. M has to be in the middle. M is the vertex. Now, let's look at the second angle. Let's look at that angle. I can call that angle KML or backwards. Angle LMK. The next angle is the big angle. The big angle would be this one right here. Okay, so I can call that angle JML, or its reversed order, LMJ. Now, how come I cannot call it angle M? Whoops. I cannot call that angle M because M has 2 different angles coming from it. It has this angle and this angle. And when that happens, you cannot call that angle M. So that's example number 1. Let's look at example number 2. Let me see if I can focus it a little better. Nope, that's the best it's going to be. Okay. Find the measure of each angle, then classify each angle. Now, I know the diagram is probably a little bit hard to see, but I can kind of help you a little bit. So we want to know what is the measure of angle GHK. GHK. So GHK happens to be this angle. I'm going to use pink. That's this angle. Now, because the angle is facing the left, we're going to read the top portion. So this angle right here happens to read between 120 and 130, right in between. So that is 125. Okay, so that is that angle, 125. Now, the next angle, because that answers A. For B, we want the measure of angle JHL. So JHL, it's facing actually left or right because it's right here at the 90 degrees. So that is equal to 90 degrees. Okay, so JHL happens to be this angle. And it just so happens to be a right angle. So that's 90 degrees. And for C, we want the measure of angle LHK. So LHK. So that is that little angle sandwiched in between those two. So this one right here. So I know that the measurement from JHL is 90 degrees. And the measure from here to here, if I can see that closely, it's about 55 degrees. So the difference between those two will give me that angle. So that's going to be 90 minus 55. And 90 minus 55 is going to be how much? I don't know, subtract it. That's going to be 40/35. And that's going to be 35 degrees. So that's measurement of LHK, 35 degrees. So that's example 2. Okay, example 2. All right, example 3. And remember, guys, I'm going fast on purpose because I'm trying to keep the video short. If I go too fast, simply go back. I also noticed there's a feature in there where you can click on a video and slow down the rate of the video so it can go a little bit slower too. Or faster, if you choose to. Okay, identify the congruent angles labeled in the quilt design. So if you look at this design, you see that this angle and this angle have the same number of arcs. And this angle and that angle have the same number of arcs as well. Let me zoom in really quickly so I can show you guys what that means. Okay, you see how this angle and this angle have the same number of arcs, and this one have the same number of arcs? That means that they're congruent. So I'm going to list them congruent. So let's look at A. A is asking me to identify the congruent angles. So I have angle G congruent to angle B and angle F congruent to angle D. Now it says if the measure of ADC is 140, what is the measure of angle EFG? So let's see, ADC, if this one is 140, notice that ADC and angle D is the same thing. Okay, so D is congruent to F, so angle EFG has to be the same as this one. So if it's 140, then the other one has to be 140. Because they're congruent. And that, ladies and gentlemen, is problem number 3. Let's look at example 4. Okay. Now it says, given that the measure of angle LKN is 145, find the measure of angle LKM and MKN. All right, so let's see here. So LKN, the whole thing is 145. Okay, now the sum of these two has to equal 145. Once we figure out what the value of x is going to be, we're going to go back and substitute it in both of the expressions so that we can figure out what each angle is going to be. So here's the thing. A lot of people make the mistake of equaling these two because they're assuming that this ray right here is an angle bisector. Do not assume that it's an angle bisector unless it tells you or you have additional information that allows you to think that that would be true. But in this case, it's not. We're going to use the angle addition postulate. So 2x plus 10, not equals, plus this angle, 4x minus 3, that's going to equal the whole angle. And according to the given, angle LKN is 145. So brings us back to algebra. Combine the like terms. That's 2 plus 4x, that's 6x. 10 minus 3, that is 7. And that's equal to 145. So then the next step is to solve the two-step equation. So 145, take away 7. Okay, so 145, take away 7 is 138. And to solve for x, you have to divide both sides by 6. And x is going to equal to 23. But ladies and gentlemen, 23 is not the answer. We still need to go back and substitute those values into both of those, because they want to know LKM, this one, and MKN. All right, so let's look at that. The measure of LKM is 2x plus 10. We already know what x is. That's 2 times 23 plus 10. That's 46. That's 56. So that's what the measure of angle LKM is. Now all we gotta do is do the same thing, but for the other angle, the 4x minus 3. Okay, so the measure of angle MKN is equal to 4x minus 3. So we're going to do the same thing. Okay, 4 times 23, we get 92. And 92 minus 3 is 89. So that's the measure of MKN, 89. Now for the last example, example 5, it says QS bisects PQR and PQS equals 24. Find PQR. Very wordy and totally not helpful if you don't draw a diagram. So I'm going to draw a diagram. I'm going to draw an angle. And I'm going to call this PQR. And it's telling me that QS bisects PQR, so I'm going to draw an angle bisector. You don't have to do a construction. Okay? And I'm going to call this S. Now, because it's an angle bisector, this angle and this angle are congruent. Now, they tell you that PQS is 24. So, because it is an angle bisector, guess what? That's 24 also. So, PQR is the sum of both of them. So, 24 plus 24 happens to be 48. And that's going to equal to the measure of angle PQR. All right, ladies and gentlemen, don't forget to do your extra practice, and we'll see you later.